Bismillahirrahmanirrahim. My name is Iman, presented to Dr. Hammad Majeed, Department BS Chemistry, and today my presentation topic is drying of garlic by using solar dryer. Garlic production and importance. Garlic is a scope that is well suited for production in all parts of the United States. It requires heavy fertilization with 125 pounds of nitrogen, 125 pounds of phosphorus and 150 pounds of potassium per acre needed for commercial production. Garlic grows best in full sun and well dried fertilized soil with some organic matter. Garlic is propagated by planting curves, not true seed. Larger outside curves produce the best garlic. It should be planted in the fall with 1/4 to 1/3 of the recommended nitrogen applied before planting and the remainder top dressed in the spring. Garlic need a steady supply of moisture with 1 inch of water per week during dry period until mid-June to ensure good sizing. Removing the scape as soon as it is visible encourages large bulb size. Garlic should be harvested when the lower leaves begin to brown and die back. Yield with climate, region, soil, culture practices but can be increased through improved farming practices and the use of high-yielding varieties. Mechanization with garlic planters and diggers can help expand production areas. Garlic importance of drying. Garlic is an important crop that is widely used in many cuisines around the world for its pungent flavor. Proper drying of garlic is critical to preserve its quality and nutritional properties. Importance of some key points. Dehydration helps extend the shelf life of garlic by removing moisture and preventing spoilage. Different drying methods like convective hot air drying, freeze drying, and micro drying can impact the retention of important compounds like allicin, which give garlic its characteristic flavor and health benefits. Careful control of the drying process is needed to minimize dehydration of nutrients, colors, and aroma in the final dried garlic product. Freeze drying at a temperature of 20 degrees was found to be an effective method of retaining high level of allicin, key bioactive compound in garlic. Proper drying is critical to reduce the moisture content of garlic to a safe level for storing and use as a spice. Drying methods like microwave hot air combination are effectively dry organic curves while retaining important quality attributes like flavor, color, formation of garlic. Garlic does not produce true seeds but is propagated by planting individual curves. From the garlic bulb, each bulb contains multiple curves that can be planted separately. Garlic curves require a period of cool weather for 6 to 8 weeks after planting to induce proper bulb formation. This cloud period triggers the development of the bulb and literal buds. As temperature warm up and dry length increase in spring, bulb formation process accelerates. The curve swells considerable to form a globular bulb with many fine roots and leaves. Proper bulb formation is dependent on adequate growth, subsequent growth under longer days. Removing flowers, stalks also help direct the plant energy toward bulb development. Garlic bulbs are ready to harvest when the leaves start turning yellow tropically in early to mid-summer, depending on the planting time and climate. Plant of garlic. Garlic is a species of bulbous flowering plant in the genus Allium. It is characterized by the following key features: Garlic plant grow about 60 centimeter tall and have large glossy green basal leaves that rise from a large white root. The bulb is covered with membranes, skin and enclose up to 20 edible bulblets called claves. The claves are asymmetrical in shape except for the small ones near the center. Small white four plated flowers are brown in terminal clusters. Flower stacks sometimes arise being tiny bulb balls and sterile bellows. Garlic is usually grown as an annual crop and is propagated by planting. Claves through seeds can also be used. It requires a period of cool weather for proper bulb formation. The plant prefers well drained, loose soil with high organic matter content in full sun. Proper spacing, watering, and weed control are important for optical bulb development. Garlic has few major insects or disease problems. The leaves, flowers, and cloves are edible and used for their distinctive pungent flavor and aroma as well as medicine properties. Garlic is a versatile, hardy plant grown for its flavorful and nutritious bulbs, which are a staple ingredients many cuisines worldwide. Plant formation of garlic. Choose the right time. Plant garlic in the late autumn or early winter, as it needs a period of cool weather to develop into bulbs. For areas with mild winter, you can plant in early spring. Prepare the soil. Clear the area of weeds and summer crops. Add compost and rake over well to loosen the soil. Plant the curves. Break up the bulbs into individual curves. Plant them 2.5 cm deep with the flat end down and the pointed end up. Space them 15 cm apart with rows 30 cm apart. Water and maintain water during dry spells and weed regularly to prevent overcrowding. Remove flower stems as they form to direct energy toward bulb growth. Harvest. Garlic is ready when the leaves turn yellow. Carefully dig up bulb with a fork. Handle them gently to avoid bruising. Dried method. Drying is a simple and effective method for preserving a wide variety of foods, including meats, fruit, vegetable, herbs, and more. The drying process removes moisture from the food, inhibiting microbial growth and extending the shelf life. Oven drying. Food are placed in an oven at low temperature to slowly remove moisture. The stove uses heat to evaporate the winter, and the resulting vapor is vented outside. They are typically used for materials sensitive to water damage, such as electronic components or chemicals. Electric dehydrator, a specialized application that circulate warm water over food to dehydrate it. But instead of cooling with heat, dehydrators draw moisture out of food so they dry out and can be enjoyed for a long time. Most ovens do not offer the same low temperature that a hydrator does. Drying, sun drying, exposing food to direct sunlight to naturally evaporate moisture. This is a low cost but less controlled method. To be successful, it demands a rainless seasons of bright sunshine and temperature above 98 degree. Considering the period of product's maturity, sun drying requires considerable care. Freeze drying. Foods are freezed, then the ice is removed by sublimation in a low pressure environment. This preserves flavor and nutrient well. This is in contrast to hydration by most conventional methods that evaporate water using heat. Proper conditioning and storage of dried food is important to prevent mold growth. Food should be sealed in airtight container and stored in a cool, dark place. The choice of drying method depend on factors like food type, desired quality, variable equipment. Drying is an ancient, inexpensive, and effective way to preserve a wide variety of foods. Solar dryer, direct solar dryer and indirect solar dryer. These expose the food directly to sunlight, often on racks and trays. The food absorbs the solar radiation and heat up, causing moisture to evaporate. This is a simple and inexpensive approach but can be less controlled than indirect methods. Indirect solar dryer. These use a solar collector to heat air which is then circulated over the food. Enclosed drying chamber allow better control over temperature and airflow. Protect the food from contamination. The heat air absorb moisture from the food as it passes through. Solar dryer. A solar dryer is another technology to harness the solar energy that is used to dry fruit, vegetable, crops for preservation. Solar dryer are of two types, direct and indirect. Direct solar dryer substances that is to be hydrated is exposed to the sunlight in a vast field. Indirect solar dryer consists of an insulated box coated inside black observation surfaces, air inlet and air outlet, and a single or double glazed glass. A solar dryer works on the principle of the density differentiation. The inlet air hole is at the lower side for the entrance of the cooled air, and the outlet is the upper side of the opposite wall. The sunlight coming through the glazing keep and inner environment warm, which dehydrate the substances. The cool air takes the hot air enriched with moisture content from the box, and because of the difference in the density, air is ventilated through the hot air outlet. Working principle, heat generation. Solar dryer utilize the heat generating from direct observation of solar radiation. This heat is absorbed by the product being dried as well as internal surface of the drying chamber. Density differentiation. As the air inside the dry chamber is heated by the absorbed solar energy, it becomes less dense than the cooler outside air. This density differentiation causes the hot air to rise and exist through the outlet, creating airflow that facilitates drying air circulation. Solar dryer are either natural convention on forced air circulation to move the heat air over the product. This can be achieved through passive designs, relay nature airflow. Active designs use fans browser powered by solar energy. Moisture remover. The heat air absorbs moisture from the product, causing it to evaporate. Moisture laden air expelled from the drying chamber, allowing the drier air to circulate and continue the drying process. Enclosure. Solar dryer enclose the drying area, protecting the product from rain, wind, pest, and other environmental factors that could degrade the quality during the drying process. Construction of solar dryer. Solar collector heat the air that will be circulated through the drying chamber. Consists of dark colored absorb the plate enclosed in the gas box. Heated air is channelized into drying chamber through vents or dust. Drying chamber where the food product are placed on racks dries, allow the heated air from the solar collector to flow over the product. Insulated to minimize heat loss, maintain drying temperature. Adjustable vents, chimneys control airflow and allow most air to escape. Air circulation use either natural convection or forced air circulation. Move heated to over product. Natural convection relies on density differentiation between hot air, create airflow. Forced air uses fans, browsers to activity move the air. Product loading. Product are placed on trays, rocks inside the drying chamber. Trays are designed to allow good air circulation around the product. Loading density and arrangement affected drying efficiency, insulation and construction material. Proper insulation of collector and chamber minimize heat losses. Common insulating material include wool, fiberglass, or foam dry structure often made from locally available wood, metal, sheet, glass. Benefit of solar drying: reduce energy cost compared to electric or fuel powered dryer. Improved food quality and hygiene to open air sun dryer. Faster drying time than sun drying. Ability to dry large quantities of food. Longer storage life for dried food. Solar dry can be simply homemade. Designs are more complex chemical systems. Proper insulation, airflow, temperature control are important for effective drying. Applications: agriculture application: drying of crop like grain, pulse, overseeds, fruits, vegetable. Drying of agriculture produce like chili, pepper, tomatoes, onion, garlic, ginger, turmeric. Drying of metal, fish and other seafood. Drying of tea leaves, coffee beans. Drying of tobacco leaves. Household application: drying of cloth, towels. Drying of medicinal herbs and plants. Drying of mushroom, uh, pickles. Drying of flour for decorative purpose. Industrial applications: drying of wood, timber, wood product. Drying of textile, fabric, yarns. Drying of paper and pulp product. Drying of pharmaceutical and chemical. Drying of mineral and ceramics. Conclusion: solar dryer are an effective and sustainable technology for drying a wide range of agriculture and industrial products using renewable solar energy. They offer several advantages over traditional sun drying mechanical drying method. Improved product quality and hygiene by protecting from contamination, pest, adverse weather conditions. Faster drying times compared to open sun drying, reduce energy cost and environmental impact compared to fuel powered dryer. Log Longer storage life for dried product, ability to dry large quantities of product effectively.